All right, you're here, I'm here. Let's get started. Good afternoon, everybody. Welcome to Monday afternoon of Chem 170 Organic Chemistry with your host, me, Dr. White. All right, important things. Remember, this Thursday after class, I'll send out the password for the, wow, everybody's showing up now. One more person. Anyways, I'll be sending out the password for the password protected PDF file that Wednesday you can download from D2L for test number 2. And as you see on your screen, I hope everybody sees it. This was sent to you as an email. It's an announcement on D2L. Test number 2 will be this Thursday. You'll have right after class on Thursday, I'll send you out a PDF or email with the password, and you'll have until Friday, next day, 11 a.m. to finish test number 2, upload your answers as a single PDF file. Should take you about 40 minutes, maybe 45, but if you need an hour and a half, just to take the test, not the part either taking pictures or scanning and uploading, just to take the test. Test number 2 has 9 pages, 10 problems. Some of the problems are multiple part. And as I've said in the past, in this class, I've never given multiple choice. It will cover, hold on. Sorry about that, my eye was itching. It will cover alcohols, thiols, ethers, ethylene oxide, aldehydes, and ketones. I'll finish up aldehydes and ketones today. And the points breakdown is general knowledge, 11 points. Nomenclature, 34. Reactions, 60. There'll be, I think, 3, maybe 4 synthesis problems, give the starting material, but the rest of the reactions will be give the organic product or products for the following. And it adds up to 105. So there's 5 bonus points. And we will have our regular Zoom meeting on Thursday and also the lab. Speaking about labs, hand in your labs. They're easy points. If you have any problems doing a lab, come to my office hour. I'm going to stop sharing this. And if you can't come to my office hour, email me and I'll see if I can set up a Zoom meeting to help you out. And we'll see if we're available sometime. All right, any questions on test number 2? All right, well, in that case, let's continue with aldehydes and ketones. Now, thumbs up, people, let me know. I believe, I'm pretty sure I did. I talked about lithium aluminum hydride on Thursday. We finished up here. Thank you. Now, you're going to have to teach me sometime this semester how to pronounce your name, CHIOMA, because I don't want to, how should I say, mangle it, but thank you. And let's do one more problem with this, because practice makes perfect. The general reaction is if you have an aldehyde or ketone, if R prime is hydrogen, it's an aldehyde. If R prime is carbons, it's a ketone. And in the first step, you react it with lithium, aluminum, hydride. Second step, acid, which is H+, and water, which I hope by now you all know is H2O. And it's the same as hydrogenation. What's attached to the carbonyl carbon? Remember, carbonyl carbon, carbon double bond to oxygen. It's still attached. but you break the pi bond between the carbon and oxygen, and each one gets a hydrogen. So let's try it out. And your turn. What would be the product or products for the following reaction? 3 points each. And when you're done, give me a thumbs up. Let's see if that works today better than polling. All right, thank you, Jordan. All right, let's try this way too. All right, I think everybody's done. Well, when you look at an organic molecule, you look for what's different. And these chapters are test number 2. And most of the time, look for what's not carbon, what's not hydrogen. And we've got an oxygen, double bond to carbon. Carbon's here, carbon's here. This is a ketone. Turns out cyclic ketone, because R prime and R double prime are connected in the ring. But it could have been an aldehyde, lithium aluminum hydride. I need a longer arrow. I need a straighter arrow. And second step acid and water. Keep your eye on the carbonyl, what's attached to it, R prime or hydrogen if it was an aldehyde, which it's not, R double prime, and the oxygen carbon, you break the pi bond, and each atom gets a hydrogen. Well, do you break carbon-carbon single bonds? No. So I immediately can do this. This all comes along for the ride. Which carbon had the oxygen double bond to it, which is this one, will have a hydrogen, but you don't show hydrogens on a ring, and we're done. All right, let's do one more. And the question is, what do you react with lithium aluminum hydride? I'll get to you in a second now. And second step, acid and water to make this compound. All right, Nana, do you have a question? You can turn your mic on or you can send it by chat.
Hi, can you hear me?
I can. Maybe.
Okay. I just wanted to see the last question just to make sure I got it correctly.
Of course.
Thank you.
I told you I have the fastest mouse wheel finger, this side and the other side of the Mississippi River. Does that help?
Yeah, thank you.
You're welcome. Now turn on your video so I can put a voice with a face. You don't have to. All right, let's take a look at this. And how do we determine what is the starting material? Well, first of all, we have to look here and say what's different. Carbon, carbon, what's not hydrogen, what's not carbon, what's not a carbon, carbon single bond. Ooh, oxygen with a hydrogen and a carbon. That's an alcohol. Then I could do this and I'll explain why. Then CH2, 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 CH3. If you think about it, I can rewrite this like this. And what do we react to make an alcohol? In this case, this could have been R prime too instead of hydrogen. And what do we react with lithium aluminum hydride second step acid and water, we react an aldehyde or ketone. And I can call this right here my R double prime, and one of the hydrogens R prime, and here's my hydroxyl group right here. If that's the case, then the carbon with the hydroxyl group, alcohol, is the carbon that will be double bonded to oxygen, in this case, the end one. So I have this. Notice I end up with 4 carbons. If this is one of them, and I need 3 more, because I didn't magically add it or subtract it. So R prime is a hydrogen. I know there are 4 bonds to carbon. And that would be the starting material. And I'll give you a chance to check and see if you got it right. Or more importantly, check to make sure I got it right. I did. All right. Now, before we move on, I need to talk about something personal. And that is the next area we're going to talk about is very near and dear to my heart. We're talking about sacred area, sacred ground for Dr. White. And that deals with an area that I'm a world expert in. And it's an area that I did my PhD thesis study in. And my last patent, my knowledge of that area helped me get that last patent. So if it looks like I'm really excited about what I'm talking about, I am. And if it looks like I'm really having a good time, I also am. Fond memories. All right. Next couple, first of all, everybody, this one, I'm going to skip for now. We'll come back next chapter and talk about this reaction. See, it even says on the screen, skip for now. I should have pulled it out of here. All right. Next couple of slides, click. Will this be on test? The switch will be in the off position. Now, when we talk about ketones and aldehydes, something they can do is form a tautomerism. A tautomerism is in an organic molecule when you move only a hydrogen and electrons. And this is called the keto-enol tautomerism. And aldehydes and ketones may exist in an equilibrium of 2 forms. One is called the keto, the other is called the enol. Ooh, see bored, I better get to work. Again, switch is off. If R prime is a hydrogen, it's a aldehyde. If R prime is carbon, it's a ketone. Now, little terminology that I'll be using. The carbon attached to the carbonyl carbon is called the alpha carbon. This is the Greek letter alpha. And then next one's called beta and so on, but you don't need to know that. The one attached, carbon attached to the carbonyl carbon is called the alpha carbon. And what can happen is, this is not a resonance form because we're moving more than electrons. And what it can do is this. Now, this is called the keto form for ketone or aldehyde. And we've got a double bond, ene, and an alcohol, OL. And that's how it got the name enol. And this equilibrium is very important because it does something that doesn't happen in like alkanes, that the hydrogens on the alpha carbon are acidic. That means you can pull them off with the base. And that's what we mean by the acidity, it's acidic, of the alpha hydrogens to form the enolate anion. Again, click, the switch is off. I won't ask like this on a test, but I'll help you understand a little while reaction I am doing. So the alpha hydrogen in a carbonyl compound is more acidic than the hydrogen on an alkane carbon, much more. And this is due to resonance stability of the enolate anion. Now let's look at an enolate anion. You pull off the hydrogen from the alpha carbon, pull it off. There should be only one there. And let's say we pulled it off with sodium hydroxide. You'd have this anion. And this is called the enolate anion. Dr. White's smiling and having a, oh, wow time. Because I like this stuff a lot. And the reason you can do this is the following. If I move the electrons here and here, now this is truly, I'm only moving electrons, a resonance form. And these are the two forms, resonance forms of the enolate anion, which makes it stable, which is why you can pull that proton off, it loses H plus to form a stable anion. Alcohols can't do that, alkanes, alkenes, whatever. Enolate can be done with the ketone and aldehyde. All right, switches on, click. There's one of the things you can do with enolate anions, and I'm only going to show you one reaction. I know a few more. You can make something very special, very rare. What's that? A carbon-carbon single bond. And enolate anions allow you to do that. And one reaction is the Aldol condensation. And the Aldol condensation, my gift to you, you can do with both ketones and aldehydes, but I will only do with an aldehyde. Now, my other gift to you on an aldehyde, aldol condensation, I'll write the aldehyde twice. You don't have to. In fact, at my level, you just write it once and you don't even put a 2 in front because everybody knows what's going to happen. Now, here's one way of doing it. Let me show you another way. Now, here's my alpha carbon. When I react this with base, I'll pull a hydrogen off there to form the enolate anion. Now, the enolate anion is looking for something positive to react with. And what's positive is the carbonyl. Remember, this is slightly positive, slightly negative. And this attacks that. Yes, we use that term. So I have this first molecule. I pulled off a hydrogen. That's what this base does. And sometimes you'll see water or alcohol. and the rest is still there. Now, this is the alpha carbon, and it bonds to the other carbon of the carbonyl, and it opens it up to an alcohol. And what's attached to it, the H and the CH2, and then R is still there. And notice what I've done. I've made a carbon-carbon single bond right here. And this is called the Aldol condensation. Ald from aldehyde. Alcohol, we use the OL, aldol. And this is a beautiful way of making a carbon-carbon single bond. All right, let's try one. And my gift to you for aldol condensation, don't tell anybody I'm being nice, is I'll write the same aldehyde twice. Now, there are other bases you can use, but I'll stick to sodium hydroxide and NaOH. As soon as you see base and an aldehyde, alpha carbon, carbon bond to carbonyl carbon attacks here, and then you pull off one hydrogen to form the enolate anion when it attacks. Remember, there's 4 bonds to carbon. And then this one opens up to an alcohol. And what's attached to it is still attached to it. And that's how you do it. Now, my other special gift to you is, boy, I'm giving you a lot of gifts. It's not even your birthday, maybe. And that is, I will never give you a synthesis problem on a test or a final with this reaction. I'll say that again. I'll never give you a synthesis problem with this reaction on test or the final. All right, your turn to have some fun. Now, you could look at the general reaction, but it's easier just to figure out where's the enolate anion and where would it attack. Like I said, I'll always give you 2 of these, so you should be able to know that's an Alvo condensation. And I'll limit it to sodium hydroxide. There are other things you could use. Your turn. Give the organic product or products for following reaction. 3 points each. Ooh, I thought of a good one. When you're done, turn on your video cam. You don't have to. Is Dr. White sneaky or what? Thank you, Jimmy. Oops, too big. That's too big. Better. Wow, it looks like everybody's done. So I better get to work. If we look at this, what's different? Ooh, an oxygen is double bond to carbon, an aldehyde, because there's a H here too. But wait, same molecule. And we're reacting with sodium hydroxide and water. This is the Aldol condensation. The alpha carbon, the carbon bond to the carbonyl carbon, attach the other carbonyl carbon to the second aldehyde. Remember, you pull off one hydrogen, there's 4 bonds to carbon. And I pulled it off. And when it attacks this one, it opens it up to an alcohol. And what's attached to this one here is still attached, 3 carbons. And that's what you get, an aldol. All right. If you look at the slide, we're done with this chapter. Now, test number 2 will be this Thursday. However, one thing I'd like to do right now is go back and cover a few more reactions again in aldehydes and ketones. Why am I doing this? Or better yet, what's the reason I'm doing this? Because these are the reactions students historically have problems with on test number 2, and this will help you. Shh, don't tell anybody I'm being nice. Wish they had where the camera was right around there instead of up there. So when looking at me, not the camera, it looks weird. All right, let's get to my whiteboard. And the first reaction I'd like you to practice. But before we do that, I forgot something. Boy, I forgot something. How many of you happen to be in a gas station or a liquor store or a Jewel where they have liquor? If you're in a gas station, see the sign, this gasoline contains up to 10% ethanol, and that's an alcohol. Or if you were in a liquor store, picked up a bottle of hard spirits, you know, the good stuff, vodka, and you see this bottle, it says contains up to, or usually those will see proof, but that contains ethanol, which is an alcohol. Did you happen to pick up a bottle of rubbing alcohol, look at it, and it says this contains either 70 or 90% isopropyl alcohol, the rest is water, and that's an alcohol? Or did you happen to pick up a bottle of nail polish remover and see it contains acetone, which is a ketone? Remember, this stuff's in your daily life. It won't hurt for you to think about it when you're not in my class. Trust me, I'm a doctor. Did that work? I am. And remember, if you start with a ketone or aldehyde and alcohol and acid, you'll get with one molecule of an alcohol. Keep your eye on the carbonyl carbon, carbon double bond to oxygen, because what's attached to it initially stays attached. And you get this hemi-ketal or acetal. And your turn. Give the product or products for the following reaction. And by the way, practice is good for your grade. Am I being subtle or what? I guess it's or what. And as promised, a couple days before, which in summer means about a week and a half before, I finished all the material coming up for test 2. Gives you plenty of time to study for it, assuming you've got the time. I hope you do. Remember, do the practice problems, keep up. Best way to study. Thank you, Jimmy. Thank you, Jordan. Wow, my 2 J's, J squared. But anyways, the best way to study for, and you got to help me out, CHIOMA. How do you pronounce that? Maybe after class, you'll show me, you'll tell me how. Or turn on your mic and tell everybody how. My last name is hard to pronounce. All right, I think everybody's done. Let's get to work. You look at this reaction, the first one. What's different? Ooh, an oxygen double bond to carbon. Remember, look for what's not carbon, not what's not hydrogen. Carbonyl, hydrogen, could have been carbons, but it's not. And carbons here. This is a aldehyde, could have been a ketone. Carbon, ooh, OH on a carbon, that's an alcohol. Acid catalyst, H+, and what do you get? What's attached to the carbonyl carbon is still attached. And this opens up to OH group and then O on that oxygen, the R from the alcohol. Remember, when there's no coefficient number in front, that's the same as saying number 1. So what's attached to this carbonyl, I can call this R prime, R double prime, R. Remember, the carbon in the alcohol with the hydroxyl group, OH, is the carbon this oxygen is bonded to up here. So this carbon I'm going to write first. What's attached to it, R prime hydrogen, R double prime methyl. And then I'll have a OH, oxygen. What's my R? And carbon has the hydroxyl. So that's what will be bonded to the oxygen on top. And I'm done. And that's how you do it. All right, while you're looking there, I'm going to write another reaction. All right, let's look at the next reaction. I'd like to review once again. If you take an aldehyde or ketone plus now, not one, but two molecules or moles of an alcohol, acid catalyst, keep your eye on the carbonyl carbon. What was attached to it? Well, I already have one of those, so I don't need it. What was attached to it stays there, R prime or hydrogen and double prime. You have two oxygens. On each oxygen is the R from the alcohol. And here's one for you to enjoy. What would be the product or products of the following reaction? And I'm going over these and a couple more reactions because these are reactions students have difficulty on test 2. And if I have you practice them now, maybe you won't have difficulty on test 2 with them. Which will make you happy. And guess what? Me too. And don't forget, tomorrow, I will do my world famous review for the next test, test number 2. And Wednesday, I'll give you enough time to try it out. I'll go through the aldehydes and ketones problem set, which you notice is longer than the other ones because I've covered more. Bad news, I ran out of tea. I still have water. All right. Is everybody done? Let me find out real quick. Super fast voting time. All right, let me start. If we look at the starting material, the first one, what's different? If I look here, I'll see, ooh, carbon double bond to oxygen, carbonyl. Carbons here and here, they're connected in a ring, but this is a ketone. Could have been an aldehyde. Remember, our prime and our double prime connected ring. Ooh, two, carbon hydroxy alcohol. Acid catalyst, keep your eye on the carbonyl carbon. What's attached to it is still attached to it. And then this becomes OH plus, oh, excuse me, wrong, OR, and this is OR. So here's my carbonyl carbon here. What's attached to it is the ring and the methyl group. Again, that's this carbon right here. So I'll have two oxygens. What's my R group right there? And that's what you get. All right, if I look at the clock, oh no, we've gone a whole minute over into our break. So that means please come back at 2:56. Let's take a 5-minute break. I can get up and stretch. I'll see you in 5. let's get back to work. All right, now that we've made these two compounds, let's go to the next two reactions I'd like you to consider. And I'm talking about this because students have trouble on test number 2 with these. And we'll learn these next two reactions is how your stomach breaks down carbohydrates. Now, if you start with either hemiacetal when R prime is hydrogen, hemiketal when R prime is carbons, reacted with oxygen, H plus acid and water. Boy, where's my brain going today? And keep your eye on the carbon with both oxygens. That's rare. There's only 2 cases, this and the next one I'll show you, in all of organic chemistry that I know, where you have 2, listen carefully, single bonded oxygen to the same carbon, not double and single, single. And what's attached to the carbon with the 2 oxygens, R prime, R double prime, or hydrogen, is still attached, and this becomes the aldehyde or ketone you would have used to make this compound. And this R group here on this oxygen becomes the alcohol you would have reacted with this ketone or aldehyde to make the hemiacetal. And here's one for you to try. On a test, I would have this to tell you they're 2 products. So give the 2 products of this reaction. Sorry about that. Something almost fell off my table over here. All right, let's get to work. We look at this molecule, look for what's different. What's not a carbon, what's not a hydrogen. Ooh, I got oxygen here to the same carbon. OH, OR. This is my R group alcohol. Then on this carbon, I have carbons here and here. And I can call that R prime, but it could have been a hydrogen, but it's not. And R double prime. Acid and water. Keep your eye on the carbon with the two oxygens, and it'll become a carbonyl. R prime or hydrogen, and the R double prime is still attached to that. And this R group becomes an alcohol. And I'll call this R prime, R double prime. You could say it the other way too. And therefore carbonyl, R prime methyl, R double prime ethyl. Remember, there's 4 bonds to carbon. We can then our alcohol here is R here, which is ethyl. And the carbon with the hydroxyl oxygen here is the one that will have the hydroxyl group. And that's what you get. All right, I'm going to move on. And as you heard earlier from one of your classmates, if you need me to back up, I'll wait a second or two. All right, let's move on. Next reaction students have problems with on test number 2, and the final 2 really, is this. And react this molecule, R prime can be carbons or hydrogen, and acid and water. H plus means acid. I hope we all know H2O is water, but anyways, this is the only other case I know where you have 2 oxygens single bonded to the same carbon, and you get the same reaction products as the reaction we just did. What's attached to the carbon with the 2 oxygens, carbon-wise, is still there, hydrogen. And this becomes double bond oxygen. And then these R groups on the oxygen become alcohols. Now, you don't have to, because I never asked you in this class to balance a chemical equation, but if it makes you happy to put a 2 there, you can. I wouldn't. I'm a lazy organic chemist. All right, let's try this out. By the way, this should be a 3. Didn't look like it, but it was. And now it's your turn. Give the organic product or products the following reaction. I'll help you out there. On tests, you can't do this. So I hope you're practicing writing down these reactions and memorizing them. It's make the students feel guilty time. You know, if you had your webcams on, all of you, I could tell you're done. That make you feel guilty. Turn on your webcam. Shucks, didn't work. All right, everybody's done. It's time for me to do my job. And that is, what's the organic product or products you're following? Oops, I should have done this. Sometimes even on tests, I forget. If I do, you can always email me and I'll let the whole class know the correction. And it's happened in class too. All right, let's take a look at this molecule. What's different? What's not carbon? What's not hydrogen? Ooh, oxygen here, oxygen here. So the same carbon. And each oxygen has carbons on it. This carbon has a hydrogen here. It could have been carbons, but it's a hydrogen. And we have carbons here. So I'll call this R prime, R double prime, and either these two, each one is R. And when you react this, the acetal or ketal acid and water, and this is the first step in breaking out carbohydrates in your stomach after you swallow it, because remember, in your stomach, you have acid and water. And I always say to think one of the great miracles of life is you and I have in our stomach cells that make hydrochloric acid, and that is astounding. So what do you get? What's attached to the carbonyl? Well, carbon here becomes this carbon double bond oxygen. What's attached to it? R prime or H, and R double prime are still there. And then this carbon, R group on the oxygen, becomes an alcohol. For those who must, you could put a 2 there. I wouldn't, but you can. So now we know this carbon here, which is this carbon, becomes this carbon. So I'll draw this. What's attached to it? R prime is a hydrogen. R double prime is an isopropyl. And think about what I just said. Isopropyl, would you have known what that is 6 months ago? See how much you're learning? And now the alcohol, this group, which is this group, notice the N carbon has the oxygen there. Therefore, 3 carbons. N carbon has the hydroxyl group, and there are 4 bonds to carbon. So I can put in my hydrogens. And I'm done. Now, I'm going to actually go full screen. I don't know why. The next reaction students have a lot of difficulty with. That means they get it wrong. And it's my favorite reaction, one of them. Ah, come on, people. All right, and I'm going to show it to you so you can practice it more on your own so you don't get it wrong. And it is my favorite reaction. And what's that? Now, making a Grignard reagent, students get like that. And I didn't, hold on. Got so excited, I forgot to switch screens. Students can do the Grignard making the reagent, but the Grignard reaction, which is one of those special reactions that you can make a carbon-carbon single bond, only a handful. And keep your eye on the carbonyl carbon. We have a ketone or aldehyde. What's attached to it, R prime and R double prime, is still there. Ooh, what's this? A Grignard. R triple prime MgX. X can be chlorine, bromine, or iodine. And remember, this is tax that opens it up to a alcohol, and you make that special thing, a carbon-carbon single bond. Very special, very rare, very good to do, which is why Dr. Grignard obtained a Nobel Prize, won it. All right, let's take a look at a reaction. And there you go. And you get only one product, organic product. Your turn. Oops, better end the poll and give people more time. Sorry. They'll help you out too. I don't know what it is this summer. I just feel, oh, it's wiped out by now. Sorry about that. Fire up, Dr. White. Yeah, I hope some of you watched last night the final game of the Stanley Cup playoff. It was an awesome hockey game. I thought the Lightning were going to win after the first period. They were just so dominant. All of a sudden, like that, the Avalanche came on in periods 2 and 3. They were dominant. And because of that, they won the game. They won the Stanley Cup. All right, it's time for me to get to work. We look at this molecule we're starting with. What's different? What's not carbon? What's not, hydrogen. Oxygen, double bond to carbon. Carbon's here and here. Our prime, our double prime, it's a ketone. This could have been a hydrogen, which would have been an aldehyde. What's different here? Carbon, magnesium halide. And that's a Grignard, where X can be chlorine, bromine, or iodine. Second step, acid and water. And you don't want to, if you react the Grignard with water and acid, you'll just get an alkane. That's why you do it separately. And remember, this attacks that. What's attached to the carbonyl carbon, our prime or hydrogen, our double prime is still there. This opens up to an alcohol, OH, and then you do that very special thing. You form a carbon-carbon single bond between the R group of the Grignard and the carbonyl carbon. So what's our prime? That. What's our double prime? That. What is our triple prime? That. So what's attached to the carbonyl carbon? Our prime, ethyl. Our double prime, methyl. Then we'll have an alcohol. And no oxygen here. For Grignard, it's a carbon-carbon single bond directly to the carbon that was the carbonyl carbon. This bond here, the carbon with the magnesium chloride is the carbon that's bonded to there. And if you notice in one step, I took the simple ketone, reacted with a simple Grignard reagent, and look at the complex molecule we made. Is that something? And that's how you do it. Now, there's a reason I just went through those problems. First of all, the ones I just did, the 5 of them, general reactions, there will never, one more time, never be a synthesis. What would be the starting materials? But the reactions I just showed you, that will be how you do it. All right, practice them. Then you'll get them right on test number 2. All right, I gotta look up. You know what? I think you people need a pick-me-up. A real pick-me-up. So it's time to play that fun game. Circle and name the functional group, 2 points each. And that's how you do it. You're not naming the whole molecule. You're just circling and naming the functional group. So let's play that fun game. Circle and name the functional group, 2 points each. And there's some fun for you. A, B, and C. Circle the functional groups in those. Don't give the IUPAC name. Circle the functional group. Circle and name the functional groups in those three molecules, 2 points each. Boy, this organic chemistry is thirsty work. And tonight at midnight, I'll be giving speed drawing lessons. No, I won't. Hopefully, he's sound asleep in my bed. All right, let's get to work. How do you know where's the functional group so you can circle it and name it? Look for what's different. What's not carbon, what's not hydrogen should get your attention like this. Got your attention. All right, let's look at A. Now I'm going to go to a different color pen to have fun. Ooh, oxygen. It's bonded to carbon here and here. You don't have to do this, I will. And what's this? It's an ether. Ooh, something else, another oxygen. Notice that's double bond to carbon with a hydrogen and carbons here. And what's this? It's an aldehyde. And let's go on to B. Again, look for what's there. Ooh, oxygen, hydrogen, and a carbon. And what's that? It's an alcohol. Are we done? No. Here's an oxygen on a carbon. It's double bonded. And notice our carbons here and here. This whole thing actually here. And what do we call this? It's a ketone. Now, remember, ketone is not spelled with a Y, but I won't take off spelling. All right, let's finally move on to C. If we look here, look for what's different. Oxygen, double bond to carbon, carbons here and here. And that's a ketone. Now, R and R prime are bonded together. It's a cyclic ketone, but this is a ketone. And if you circle a little more, are we done? Well, I'm looking for what's different, what's not carbon, what's not hydrogen. Ooh, another option. Carbons here and here. And we call that an ether. And finally, we're not done. Oxygen, double bond to carbon, hydrogen carbons. And what do we call this? An aldehyde. And that's how you play that fun game. Circle and name the functional groups, 2 points each. I hope you had fun. I did. All right. And seriously, if you don't know if something's an aldehyde, an ether, an alcohol, or ketone, how are you going to name it? You don't know how. How are you going to know how to react it? You don't know how. And that's where this helps. The exercise, that is. Uh-oh, I got dinged again. Hold on. All right, let me do something and then I'll be right with you. Nope. All right, I'm up to date. We should be good to go. All right. Guess what? We finished a chapter. And I've covered everything now that will be on test number 2 this coming, I guess it's that away, maybe that away, this coming Thursday. So you should be studying that and doing the practice problems. But I have to move on. And I do this every summer and I'll actually fall in winter too. So guess what time it is? It's new functional group time. And this new functional group actually will have more than one. It's going to be really exciting. I'm going to teach you my father's secret recipe for spaghetti sauce. Shh, keep it secret. And I'm going to get into stuff. He's talking about that. And I'll be telling you a very personal story that happened to me in high school. And is he talking about that? Yep. And parts of this chapter will smell really, really good. And finally, a cliffhanger, you're going to have to wait because I don't know if we'll get to it today, is I'll talk about the first chemical reaction I ever did with my hands. Your body's always doing chemical reactions, but I was only about 5. Yep, I was doing chemistry then. And you'll find out what a cool guy my father was, and he was. All right, what's all this going to be? Well, it's chapter on carboxylic acids and their derivatives. Thumbs up, people. Do you see chapter 10 on your screen? Thank you, Jimmy. Now, I'll teach you what a carboxylic acid is. What is a derivative? That's something derived or made from. So I'll teach you about carboxylic acids and new functional groups that are made from carboxylic acids. So carboxylic acid, new functional group, and I'll show you in the next slide, contains a carbonyl. Remember, carbonyl group, carbon, double bond to oxygen, and a hydroxyl group on the same carbonyl carbon. That's called a carboxylic acid. Now, the general form for drawing a carboxylic acid, now my software doesn't like to put it in carbons here. You can do it that way, or more likely, if I'm handwriting it, it will look something like this. And these are carboxylic acids. Now, sometimes you'll see it written in a book like this or like this. But on tests, I'll try and draw the structure like this. And this is a carboxylic acid. And that's a carboxylic acid. So next question is, did I spell that wrong? Yes, I did. Thought I was doing it. It's bad spelling Monday. There we go, carboxylic acid. Now, let's talk about, and this chapter, I introduced you to a carboxylic acid. If you missed it, let's do it again. As soon as I open a white, hold on. I had it open. All right, let's look at this molecule. All right, if we look at this molecule, we'll look for what's different. What's not, oops, I've made a mistake here. Now we got it. What's different? Ooh, oxygen here, oxygen here. If we look at this carbon, it's double bond to oxygen with a hydroxyl group. And here I have carbons. And this is a carboxylic acid. So how do you name it? You find the longest chain with the carbonyl carbon. So if we count this one, 1, 2, 3, 4, 5, 6, 7, and that's heptane. Drop the E. Huh. All right, let's make sure you see this. So you drop the E at the end of the alkane name and replace it with the letters OIC and the word acid. And let's go do that. So longest chain, 7 carbons, the only chain. Heptane, drop the E, add OIC and the word acid. Now the carbonyl carbon in a carboxylic acid is always number 1. Therefore, you don't need a number. I'm done. Heptanoic acid. Again, find the longest chain with the carbonyl carbon. Name it as an alkane. 7 is heptane. Drop the E, add OIC and the word acid. Heptanoic acid. Now, just like in an aldehyde, the carbonyl carbon is always number 1. And then if you had alkyl groups, you do it the same way you did with other alkyl groups. Oh, let's try one. Oops. I just lost my train of thought here. Sorry about that. And here's one for you to try. I was thinking ahead of something. I got lost. I'm back. Give the IUPAC name for this molecule. I hope you enjoyed playing that fun game. Circle and name the functional group, 2 points each. Hint. Oh, that was fast. All right, I better get to work. Thank you, people. Making my heart feel good. You're getting this. You should feel good. All right, how do we name this? We look for what's different. What's not carbon, what's not hydrogen. Ooh, on this carbon, we have an oxygen here, an oxygen hydroxyl group, carbon double bond to oxygen, hydroxyl group, and I got carbons here. And what is this? This is a carboxylic acid. And how do we name it? Count the longest chain. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So the longest chain, 6 carbons, 1, 2, 3, 4, 5, 6. 6, hopefully you learned by now, is hexane, but it's a carboxylic acid. Drop the E, add the letters OIC and the separate word acid. So I'm going to do that. And am I done? No. As soon as I say hexanoic acid, that's spoken for. Carbonyl carbon is always carbon 1. On carbon 2, ooh, I've got an isopropyl. So that would be 2 isopropyl hexanoic acid. I did it again. I'm sorry. Went over a whole minute. It happens when you're having fun. Let's come back at 3:51. If you don't have a digital watch, that's when the big hand is 1 notch past the 10 on a dial. See you in 5. let's get going again. Don't forget, this Thursday, test number 2 after our class and lab. Don't forget tomorrow, make sure you hand in the lab that's due tomorrow. And also let me remind you that I have my office hour tonight from 6 to 7 on Zoom. And if you have any questions or need any help, always feel free to stop by. All right, let's continue on with carboxylic acids. And a carboxylic acid is a R group. It's a carbonyl, carbon double bond oxygen. That carbonyl has a hydroxyl group. Remember, find the longest chain with the carbonyl carbon, name it as an alkane, drop the E, and add OIC to the end and a separate word, the word acid. And let's have some fun. Oops, that's 2. And here's something for you to have fun with. Give the IUPAC name for the following. And remember IUPAC, which really stands for International Union of Pure Applied Chemistry, is in my class for you. Give the official name. Have fun. And don't forget, you can see your favorite YouTube star, me, Dr. White, on my Chem 170 YouTube channel. If you ever come late or want to see this again, or for those of you who are learning by my YouTube, hi. One person is still working on it. We'll be patient. Excuse me. Success. All right. Question is, how do you name this product? Well, not product, molecule. And you look at it, look for what's different, what's not carbon, what's not hydrogen. By the end of the semester, you'll be having nightmares hearing me say that. But really, when I look at a molecule, I do that. And I see oxygen here, it's the same carbon, carbonyl, hydroxyl group, carbons here. And what is this? This is a carboxylic acid. And you find the longest chain with the carbonyl carbon, name it as an alkane, drop the E, and replace it with OIC, and separate word the word acid. Well, let's get to work. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, longest chain, hope you agree, 9 is greater than 6 and 4. Isn't the math hard in my class? And 9 is no name. Drop the E, add OIC in a separate word acid. The carbonyl carbon is always number 1, so you don't need a number 1 in front of there. And then, oh, look, if we say that, this is all spoken for. Oh, it's your favorite group, the methyl group, and a T-butyl group, my favorite group. And if we count, this is 1, 2, 3, 4, 5. So this is 2 T or tert-butyl, then 5 methyl, nonanoic acid. Now, don't tell anybody, but if you have 5-methyl, 2-tert-butyl, or T-butyl nonanoic acid, I give you full credit because I'm not holding you to the alphabet rule. Now, when it comes to nomenclature, there's two types of skills organic chemists could have, which means there's 2 types of questions I can ask you, nomenclature questions. Remember, nomenclature is a fancy word meaning to name. So how do we do that? Well, the second type is draw the structure for the following name. And let's see how to do that. I'll do one, and you know I'm going to share. I do. And we start, how do we decode this? Secret words to know what to write. You start from the right and go left. OIC in the word acid, that's a carboxylic acid. And if this were an E, butane, is 4 carbons. Now, as I mentioned, I think in the past, with alcohols, ketones and aldehydes, especially aldehydes, and carboxylic acids, I'm going to always start on the right. You can do it on the left, but I learned it on the right. I like to do it on the right, and good habits I don't change. So I have my carboxylic acid. This is carbon number 1. I'm going this way. Ooh, my old friend, your friend, the methyl group, and it's on carbon 2. I know there are 4 bonds to carbon. And that's how you do it. 2-methyl butanoic acid. Now, before I move on, it's time for a public service commercial from me, Dr. White. For test number 2, your good friends will be how many bonds to carbon? 4. 4. Yes, 4. Really. Anytime you write down a structure, make sure anything you've changed has 4 bonds to the carbons. Next, what will be your friend on test number 2 and 3, 4, and the final is, do you break carbon-carbon single bonds? No. Do you break carbon-carbon single bonds? I'll do this in slow motion. No, you don't. Remember that. 4 bonds to carbon, you don't break carbon-carbon single bonds. All right, back to our regular scheduled nomenclature discussion. Look out, I'm on a roll. And it's your turn to have some fun. And here's one for you to draw. 3N-propyl decanoic acid. Your turn. All right, time for me to get to work. All right, how do you decode this? You start from the right, move left. Ooh, the word acid, OIC, and OIC, and the word acid ending, that's a carboxylic acid. So if this were an E decane, 10 carbons, I better get to work. And at one end, and I'm going to do the right, you could do the left, you have a carboxylic acid. And this is carbon 1, 2, carbon 3. I have an N propyl, 3 carbons. The N carbon is bonded to chain. I know there are 4 bonds to carbon, so I better get to work. And there we have 3N-propyl decanoic acid. Oh, this was fun. Let's do one more because I'm having a good time. And remember, this is material that'll be on test 3, not test 2. Again, this material will be on test 3, 1, 2, 3. Let's do it again, 1, 2, 3, 3, not test number 2, 1, 2. Give the IUPAC name for the following molecule, 3 points each. And by the way, in case you can't read my handwriting, that's 2,4-dimethyl octanoic acid. Wrong thing. And remember, if you finish early, I try and give everybody time to finish. So finish. Actually, I do give you time to finish. And remember, tomorrow I'll be doing my world famous review for next test, test 2. All right, time for me to get to work. How do you decode this to know what to draw? You start from the right, move left. OIC in the word acid, that's a carboxylic acid. And if this were an E and this was gone, octane is 8 carbons. And the N carbon has this carbonyl carbon hydroxyl group. I put it on the right. You can put it on the left, but I won't. I like this better. And as I go, oh, methyl CH3 di, that means 2, and they're on carbons 2 and 4. Carbonyl carbon is always number 1 of a carboxylic acid, just like an aldehyde. This is 2, 3, 4. And a carbon 2 and 4, I have my good buddy and your good buddy, the methyl group. And now there are 4 bonds to carbon. Yep, 4. This way you don't see my 4. That makes it easier anyways. And I'll put in my hydrogens. And I'm done. 2,4-dimethyl octanoic acid. 4 plus 4 more is 8 carbons, the longest chain. And that's how you name carboxylic acids. Now I have a number 5 and I'll never put that on test. I don't use it that often even. When a carboxylic acid is attached to a ring, not a benzene ring, the ending carboxylic acid is added to the parent name cycloalkane. I will never put that on a test or the final, but at least you know about it. All right, now there are a couple of key common names that you should know for carboxylic acids. And these common names, let's see if I can make this a little there. I think I can get it all in. These common names, I asked, here's the name, you should know how to draw the structure. And the first one is formic acid. And that is when R is a hydrogen. It can be. And this is formic acid. Now, how many of you, and give me a thumbs up if you have heard about the fire ants, mainly down south, Texas and Arizona, I'm not sure, but down south, they've had problem for a number of years, fire ants. And these are these ants that have a defensive weapon when they're attacked. And the defensive weapon is they spray the attacker with a hot liquid that makes them feel like they've just got burned, which is why they're called fire ants. And what is that liquid? It's a heated solution, their body heats it up, of formic acid and water. And that's what the fire ants spray, formic acid solution. Now, you probably, hopefully, never encountered it. I have once, someone else, and that's if you get certain chemicals on your skin, which you don't want to, we call that an acid burn. And why do they call it a acid burn? Because, and I actually had one student who got an acid on his skin and he didn't follow directions. That was at the other school in a lab, and it burned. And afterward, it looked like you put hot metal on your skin, burn yourself. And that's why they call it an acid burn. Now, Dr. White, thank you. It's always careful around acids. I've never had an acid burn, but that student unfortunately wasn't careful. All right, let me do this. Now, the next one is acetic acid. And acetic acid is a carboxylic acid where R is the methyl group. Again, carboxylic acid, carbonyl hydroxyl group, R group. And acetic acid, you should know, nobody ever calls that ethanoic acid. They call it acetic acid. And that's that carboxylic acid. All of you have, I bet, or most of you have acetic acid in your house. Dr. White, I'd know if I had acetic acid in my house. Well, you do. And where do you find that? Well, if you take about 4% acetic acid and about 96% water, mix them together, you have a homogeneous solution. And we have a name for that mixture. Vinegar. All vinegars are acetic acid and water. Give or take a 4, roughly right around then, maybe a little higher, 4.2, 4.3, the remainder water. And no matter what the vinegar you use, it's essentially acetic acid and water, and then some other flavors in there. But that's vinegar. Now, the next time you happen to be in your kitchen, if you don't want to look at a bottle of vinegar, pick up a bottle of ketchup, and you'll see one of the first ingredients is acetic acid or vinegar usually, and that has acetic acid. If you pick up mustard, that has vinegar in it, which is water and acetic acid. If you pick up relish, how many of you are familiar, and if you're from the Chicagoland area all your life, and you go to hot dog stands, even though a lot of them are closed down, but when I was a kid, we used to go, or my parents, it would be a treat. We'd have dinner and we go to a couple of hot dog stands that were favored by our house. One was, I still remember it, in Evanston called Chuck's Hot Dog Place or whatever. And another one was Fluky's on Western by Tui. Oh, those were good places. And you know how in the hot dogs, you can get it now, Portillo. I'm sure I haven't been to Portillo in over a decade. But anyways, you have the green relish that glows in the dark, that super green stuff we use in Chicago. If you look at the label, the liquid it's in has vinegar. So those are all mixtures that have acetic acid, a carboxylic acid. Now, the last common name you should know, I'll never ask, here's a structure, what's the common name? But on a test, I could say, draw the structure for benzoic acid. And what's that? That's when R is a benzene ring. And this also is the IUPAC name. And this is another case where IUPAC, in their infinite wisdom, and I mean that with all the greatest respect I can muster up, that's got vinegar and acetic acid. And that's benzoic acid. And I don't know if I'll get to today, but a derivative of benzoic acid, something made from that, helps keep your BOP stable. It's a preservative. So formic acid, when R is a hydrogen, that's in the fire ants. That's what they use with water. I hope I never see one anywhere. That's the fire ants, part of their defensive weapon. When R is a methyl group, acetic acid, nobody ever calls that ethanoic acid, except say you just don't. and you mix that with water, you have vinegar. And finally, when R is a benzene ring, you have benzoic acid. And that's both the common UPAC name for that. And those are some important carboxylic acid common names. Oh, I was going to show you something. Let me just close this down because it was yelling at me. You've been away too long. All right, how many see on your screen Marucan rice vinegar? And the regular label here, this stuff is good. It's good. It's not cheap, but it's good. Wow, they even have it in Jewel Osco. Years ago, you had to go to a Chinese or Japanese place, and I keep it in the house. And I usually get the gold as opposed to the regular, this one. And I keep a bottle in my house. Now, oh, I do have time. Public service. If you like oil vinaigrette dressing, and I do when I have salad, sometimes I go without, or make your own cabbage coleslaw, use instead of regular vinegar, or I like apple cider vinegar. They all have acetic acid and water. Use that Marucan, some vegetable oil, put in some garlic, a little sugar, salt, and pepper. Put that in a Cuisinart, the right ratios. You can find that online. And if you whip it up good enough, it's almost like a mayonnaise. It's real thick and it's so good, so good. That vinegar is the best. All right, now you learned something I shouldn't have told you about me. Let's get back to work. Now, I'm going to turn the switch, click to the opposition. We have long chain carboxylic acids. That's where, here's my carbonyl carbon. I'll rewrite this. And when the carbonyl carbon and this, and I really should do this. When this and N is a very high number, this carbon, these carbons, these, when it's 12, we don't call that dodecanoic acid. The common name is lauric acid. And palmitic acid is hexadenoic decanoic acid. Nobody calls that palmitic. And stearic is 18 carbons, and oleic is 18 carbons with a double bond. Don't right now, switches off. I just want to introduce you, say hello, long chain, long, big carboxylic acids. And why in blue, we'll talk about it when we get into fats and oils. But I worked for a company where we made, it was in the south side of Chicago, by not far from the old Comiskey Park, 47th and Racine. And we made stearic and oleic acid to the tune of about 2 to 3 million pounds a week. Yep, we're talking big time, 2 to 3 million times a week. All right, switch still off, but here's a couple of interesting things. Here's lactic acid. I'll never ask you what it is. How many of you have ever worked out with weights or running or whatever, and you feel that burning sensation in your muscles? Well, somehow your body, when it's overworked, your muscles forms lactic acid. And notice this lactic acid has a carboxylic acid. You could write it this way, My software likes to do that. And the alpha carbon, yes, carbon bond to carbonyl, you have an alcohol. And this is lactic acid. And for however it does, I don't know why, Mother Nature has it produced in your body, tell you, yeah, you've done enough, slow down. And that's what gives it a burning sensation. You're forming that in your muscles. You see Dr. White's muscles? Now, I'm going to talk about something that, don't get upset, but this is straight organic chemistry. One of my favorite mental pursuits as being an organic chemist is if I go into a big box store, supermarket, and I wonder, how did they do that with that product? Now, there's a certain product that is called personal lubricant. And the personal lubricant made by one best company, KY, is for some personal activities. And a number of years ago, they came out with a new product called warming gel, that when you used it during that personal activity, certain personal parts of your body got warm and tingly. And I figured, how the heck did they do that? So I went to my local Walmart. I happened to be in there buying stuff. I stay out of Walmart. It's a dangerous place for me to walk into. I only go a couple of times when I have to really need stuff, and they sell it at a good price. Otherwise, nope. Anyways, I go to where it is, and nobody in any store will ever get upset if you pick up a box and read the label. And being an organic chemist, I looked, and near the end, I saw lactic acid. And it warmed by giving a very minor acid burn. That's what warmed up those private parts during that private, how should I say, activity. Well, after a year or two, they changed the formulation, and they had some long chain alcohols that, because of the moisture on the skin in that certain part, the heat of hydration forming hydrogen bonds did the warming up, no longer an acid part. Wonder if they got sued or something. I don't know. And it took me a while to figure out a newer product called fire and ice, but I won't go into that now. All right, again, switches off, but I thought you'd like to learn about these things. Here's how my software wrote it. I didn't want to fight with it, but let me write it this way. And this is called citric acid. How many of you have ever had real strong lemonade? Or better yet, how many of you ever bit into a lemon? No one? Why? You've been, anyways, if you ever had lemonade or tasted a lemon, it's got that, ooh, is that tart? And limes do too, not as much as lemon. What gives the lemon that, ooh, that's tart? I don't like tart stuff. And that's citric acid. The more citric acid, the more tart something is. Lemons have more citric acid than limes. That's why lemons taste more tart than limes. And Dr. White loves lime. I'd make actually limeade instead of lemonade, where you squeeze limes in the water, put a little sugar. Is that, oh, excuse me, good. Now, citric acid is a solid, white solid at room temperature. And it dissolves nicely. And if you look at it, it has not only one, no, two, actually three carboxylic acids. And right here, you have an alcohol. So it's got a lot, Mother Nature, the stuff she made. Now, why that tells your tongue to tell your brain, oh, is that sour? I have no idea. That's not my area of expertise. Now, I do know that organic chemists for a long time found a way, instead of squeezing them out of lemons, how to make that synthetically in the chemical plants. And if I wanted to, and if I had the money and the letters of credit, which I'm not going to, but if I wanted to, I could pick up the phone right back there, call a reputable company that makes that, and in a week or so have, I don't know, 50,000 pounds delivered to my plant, which I don't have, but you could. Now, how many of you are familiar with the trend in the last 10 years or more where kids like super, super sour candy? Any of you seen that? You know, they sell that candy that's, oh, is that sour? I don't like that, but kids do. And how do they make it super sour? They just put in more citric acid. Now, a year or so ago, my favorite place, the Spice House, if you're making certain ethnic dishes, sweet and sour meatballs, or Asian has sweet and sour dishes, and I'm sure other cultures do too, you can squeeze lemons in there, or you buy citric acid and put some in. So I bought some from the Spice House, the quality what they sell. I got it, and I said, I wonder how sour it is, and did a stupid thing. Oh, is that sour? This is 100%. Wow, glass of water, rinse out my mouth. It was so sour, but it was sour. So that's citric acid. That's a carboxylic acid. Again, switch is off. Switch is still off. Now, certain low molecular weight carboxylic acids have sharp, unpleasant odors. You can smell vinegar, but you go to 4 carbon, and I had someone break a bottle of that in a lab I was managing, and smells like somebody just upchucked. Oh, it was disgusting. Only thiols smell worse than that compound. Oh, it was bad. But anyways, now the lower MW means molecular weight, how many carbons, has a sour taste. Vinegar is sour, it's a low molecular weight carboxylic acids. Now it's polar, and I'll teach you later in the semester what that means. And they have high boiling points because they can hydrogen bond. And again, switches off for this whole slide. And the lower molecular weight carboxylic acids, like vinegar, 2 carbons, are soluble in water. When you get to things like stearic acid and oleic, they are and are not really. All right, carboxylic acids are called acids because when you put them into water, they dissociate, yielding the carboxylate anion and the hydronium ion. And you don't have to worry about the wording here, but let's look at the next slide. What's an acid? Well, in chemistry, in general, we call this an acid. Switches on now. And B, ooh, that's a base. And you have an acid-base reaction. Remember, an acid is a proton donor. Proton is H+, and it goes to this. And usually it's an equilibrium. I really should have written that. Now, here's a carboxylic acid. Water is a weak base, and you get, this is called the carboxylate anion. And another way of drawing it, my software doesn't put in the carbon there, is this. And that's the carboxylate anion. And that's because carboxylic acids, the acidic proton is always the hydrogen on the oxygen. Oh no, if I look at the clock, we're just about done for today. So I better do once more public service announcements. Don't forget, hold on, this is thirsty work. Don't forget, tonight from 6 to 7 on my Zoom channel for office hours, I'll have my office hour. Come by if you have any questions. Also, tomorrow, that way is, I guess, Tuesday, I will be doing the review for test number 2. And on Wednesday, I will go through the aldehydes and ketones problem set. And don't forget, the lab we did last week is due tomorrow, I guess that way. And with that, if I look at the time, I'm going to let you out a whole 60 seconds early. And with that, I'll say, gang gesund, goodbye. Either see you tonight or tomorrow. Bye.